Alright, let's get into one technique for debugging, which is environment diagrams. Environment diagrams will be especially useful in your exams because you won't have access to a live computer. So it's important to be familiar with how to use environment diagrams to map out and debug your code. Additionally, when you do have access to a computer, environment diagrams are still useful, for example, Python Tutor, because they allow you to really see inside of the body of your function, right? To rip away that black box and see the state of your function after each line of code is executed. So let's try out this debugging method for that isPal function that we mentioned earlier. So here I have the same isPal function code that's bugging out and failing our tests from that previous video. And for now, let's ignore this reverse list function. We can treat it like a black box. Just know that it expects a list as an input, and it will return that list reversed. And we can assume that's working properly for our purposes. We're going to focus on the isPal function. So here we have isPal taking in a list of 1 and 2, and ideally this should return false. Let's see what happens when we walk through it. So first, in the global frame, isPal and reverse list are bound to their own functions. Alright, so when isPal gets called, its parameter x is bound to a list of 1 and 2. Then the variable temp also points to that list 1 and 2 because temp is assigned to x, and that's what x points to. Oh, whoops. Alright, the next step is a call to reverse list occurs, so a new frame is opened. Reverse list takes in a list, okay, that points to 1, 2, that makes sense because reverse list was called on temp, and that's what temp points to. Alright, and then reverse list, awesome, it successfully returns our original list, but reversed. Okay, and then what happens next is x and temp are both pointing at the same list, and so true is returned, even though this list is not a palindrome. Okay, that makes sense. We're always comparing the same list to itself, so of course temp equals x, and true will always be returned. I'd like you to either pause this video or consider for a second how we can change the code so that this function will behave as expected. Great. So I'm just going to talk about one way you could fix this code, right? So the issue here is that reverse list is successfully returning the list reversed, but we never actually assign anything to the return value reverse list. So instead what we can do is assign temp to the return value of reverse list. Instead of assigning temp to x, right? So now reverse list will get called on x, return the list reversed, and we'll store that in this temp variable. And then we'll check whether temp and x are equal, because if they are, that means that x reversed is equal to the original x, and it's a palindrome. If they're not equal, that means x reversed is not equal to the original x, and it's not a palindrome. Makes sense? And if we walk through our code again, we see when isPal is called on the list 1, 2, x is bound to 1, 2, a call to reverse list is initiated, where reverse list returns a new list with x reversed. Temp is bound to that new list. Temp does not equal x, and so isPal returns false. Awesome, that's what we wanted. Now let's edit our code to match what we tried on the environment diagram, and then we can run it and see whether our doc tests pass. Cool. So, alright, awesome. So my isPal doc tests aren't failing anymore, which is great, but my isPal end doc test is still failing. So we can try debugging that next. All right, so next, let's try, what about situations where an environment diagram isn't necessarily useful because our code is so large and complicated? For example, you can imagine with the Hog project, there are several different functions, each calling each other. Copying all of that code into Python Tutor may get really messy and hard to follow. In those cases, another way of visualizing the state of the function at each step is using print debugging. Print debugging is a way to add print statements within your code at specific lines to check the state of your function at those lines. The thing about print debugging is you need to be a bit more conscientious of where you're adding your print statements, right? You need to decide for yourself, what are the points in the code where I really need to check the values of my variables, and what do I expect the values of those variables to be at each of those points in the code? So let's try this example for isPal of end. All right, so isPal end. It looks like inside this body, I have several variables, and then at the end of the function, I have a call to isPal on result. Here, I'm expecting result to be the first n values of the list, right? Because I want to check whether the first n values of list are a palindrome. So it makes sense for me to be calling isPal on just those first n values. And given that we've already shown that isPal is behaving as expected, as long as result is the value that I expect before this call, then the rest of the code should behave and work properly, because it just relies on a function we've already confirmed. So it makes sense to first add a print statement here. Let's say, yeah, let's just print out the result and see what that looks like. All right, so given our print statement, it looks like result is just bound to 1 before the call to isPal on result, right? So right here, we see that result is bound to a list that just contains 1. Okay, that's not ideal, but it helps us know something. We know the result is not bound to what we want it to be, which is the first 3 elements of the list, a list containing 1, 2, 1. All right, so then we see in the body of this for loop, result keeps getting reassigned. It might be useful to add another print statement in here where we print out result at the end of each for loop. Let's see what that looks like. All right, so it looks like at the end of the first for loop, result is bound to a list containing 1. At the end of the next loop, result is bound to a list containing 2. At the end of the next loop, result is bound to a list containing 1. And then we have another print statement right before the if statement, and the list is still just a single list containing 1 element. All right, so this is kind of helpful. It looks like the result is accessing the elements we care about, but not actually growing or adding more elements as it goes on. It looks like some overwriting is happening. I'd like you all to take a second and, given the clues we have here and the code you have here, try to figure out what the bug is. So please try pausing, taking a look at the code, and I'll be here in 5 more seconds. Great. So the next step here is just kind of looking at what happens in the body of this function. So it looks like here, at the beginning of every for loop, we bind result to an empty list. Then we bind elem to list of I. Okay, that makes sense. Based on last lecture, we went over how range returns a list of all the elements from 0 to n. So I is just taking on each of the indices in the list and then pulling out individual elements. So this looks good. And then result is bound to the result list with the new element added onto it. I see. So the problem is that we keep assigning result to an empty list at the beginning of every loop. That's why this keeps getting overridden, right? First result is the element 1, then it gets bound to an empty list, so 1 is erased. Then result is bound to the next element, which is 2, but at the beginning of the next loop, result is bound to an empty list, so that element gets erased. Finally, result is bound to the element 1 again, but that's the end of the for loop because we only were grabbing the first 3 elements, and so it exits the loop, the result was printed again, and then isPal was called on a single list 1. And so that's a palindrome because 1 is the same forwards and backwards. Alright, so we found our bug. Let's move result out to outside the for loop and see whether we can pass our tests. Looks like we're no longer passing the tests. This is just because we need to get rid of our print statements. So another thing about doctests is that they're checking for exactly the expected output, and in this case, because I kept my print statements in, we're not getting the exact expected output. So if we get rid of these, let's see if they pass. Awesome. So here, no news is good news. If you run all your doc tests and you get no output, that means nothing's failing. You'll get an output whenever some of your doc tests fail, and it'll only show the doc tests that are failing. Great. So now we've successfully used doc tests, environment diagrams, and print debugging to fix 2 buggy functions.